Hello, and welcome to this special extended edition of Setting the Standard, the podcast about wireless radio standards creation from the Wireless Innovation Forum. I'm your host and Communications Director of the Forum, Stephanie Hamill. Today I'm handing the mic over to Forum CTO Andy Clegg of Valo Analytica as he spends some time with FCC Office of Engineering and Technology Chief Andy Hendrickson.
Well, thank you very much, Stephanie. And today we are very pleased to welcome Andy Hendrickson. He is the chief of the FCC's Office of Engineering and Technology. And as a leader of the Commission's engineering and technical arm, he guides the analysis behind many of the FCC's most important decisions affecting spectrum, wireless innovation, and emerging technologies. Andy was appointed by Chairman Brendan Carr back in August of 2025, so not that long ago, almost a year. He has helped shape the technical foundation for advances in AI-enabled wireless networks, expanded the use of the 6 gigahertz band, which WinForum has been very active in, and also the emerging era of direct-to-device satellite communications, which is a very interesting area. So thank you very much for joining us, Andy. I like your first name, by the way, but thank you for joining us today.
Thank you, Andy C. I'm going to refer to you as. It's always interesting to get emails from another Andy. So
yeah, very good. Very good. All right. So thank you very much. We do have our nice list of questions that we've prepared in advance, and I think it covers the gamut here. So we will start with those. So first of all, for those who are not familiar with Andy, he spent over 2 decades in the private sector. He led 5G and cloud platform deployment at Verizon. And then he served as the CTO of the FCC's Enforcement Bureau, which fortunately, I had no connection to him there. I didn't get any enforcement actions going. And he's now the chief of the Office of Engineering and Technology. So how has seeing the wireless ecosystem from both the commercial deployment and enforcement angles shaped your approach to leading the OET?
Well, once again, thanks, Andy. Well, one of the things I've definitely come to appreciate over the course of my career is that the actual engineering, itself doesn't really change. You still must work within the laws of physics, whether you're doing commercial wireless network or evaluating a new technology at the FCC. I mean, really what has changed or what changes is your perspective, and the mission, that you're kind of trying to accomplish. In the private sector, my focus was on building and operating very large-scale networks that could deliver, new capabilities to our customers. 5G leading towards 6G. Certainly gain a deep appreciation for the complexity of deploying infrastructure, managing spectrum efficiency, introducing new technologies, while certainly trying to maintain the reliability of the networks themselves. So innovation moves so quickly. There's always pressure to improve performance, reduce costs, and bring these new services to market. My time in enforcement was very different. It was a different perspective, reinforced how important it is to ensure, that everybody operates within the rules, that spectrum, remains a reliable shared resource, right? So interference, isn't just, a technical issue. It can affect public safety, critical infrastructure, businesses themselves, and consumers. So the experience certainly underscored the importance of objective technical analysis and consistent application of engineering principles. Now, taking that and moving over into OET, I mean, those experiences sort of come together for me. In OET, our role is to provide the Commission with technically, rigorous analysis that helps enable innovation while protecting existing spectrum users. Right. So we don't advocate for any one particular technology over another. Instead, we're evaluate how emerging technologies can coexist. So I think coexistence is a big part of my life, making more efficient use of spectrum and how the Commission can establish, technical frameworks that support a continued innovation. So certainly one lesson I've carried throughout my career is that good engineering creates good opportunities. And when technical decisions are grounded in sound science, right, transparent analysis, and real world testing, everyone sort of benefits from these established providers and startups to researchers and ultimately the American public. So the philosophy here, as I try to bring to OET every day, is remain creative, in enabling new innovative technologies.
Okay, so you moved from corporate tech leadership to public policy.
Yeah.
That's a pretty big transition. So, from your perspective through that transition, what's the most rewarding or surprising part of translating the rapidly evolving engineering realities that you were talking about into good regulatory decisions?
Well, I mean, one of the biggest surprises for me was actually, when it came inside, was just realizing just how much engineering goes into good public policy. People often think of the FCC primarily as a regulatory agency, but behind every major decision is an enormous amount of technical analysis, testing, modeling, and collaboration as well. In industry, we measured success by building, the best network for consumers that we could. At the FCC, success is measured a little differently. We're thinking about the entire communications ecosystem, commercial providers, satellite providers, broadcasters, public safety, researchers, equipment manufacturers, ultimately, again, the American public. Every technical decision has to consider how these different users can successfully coexist. There's that word again. So what I found most rewarding is helping to create an environment where innovation can flourish. Good engineering doesn't slow innovation, it enables it. When the technical framework is well designed, companies have a greater confidence, to invest. Researchers have room to experiment, and consumers benefit from new services and technology. So another thing certainly come to appreciate is the value of transparency. At OET, we rely on data, measurements, technical analysis that can withstand scrutiny. The public record is an important part of that process. It's something I certainly learned by coming in to do public service. Whether or not ideas are coming from industry, academia, conversations that we have with standards organizations and other stakeholders, that collaborative approach, produces better technical outcomes. So ultimately, I see OET's role as helping ensure that the commission decisions are informed by sound engineering so that innovation and spectrum stewardship can advance together sort of and coexist.
So, you mentioned that, most people see the FCC as a regulatory agency, and I think that's, definitely true. Far fewer people understand what OET does specifically at the FCC. Can you sort of walk us through the types of questions you deal with on a typical day and why those decisions that you're making matter to consumers and the industry at large?
Andy, it's a really great question, and certainly being still somewhat new to OET, OET's work happens behind the scenes a lot, both for external stakeholders and internal as well. So even though it's touching nearly every aspect of modern communications, there's a lot that could happen in the course of any given day. So at its core, the OET's mission, is engineering and being a technical resource to the commission and to our stakeholders. Our responsibility is to provide technical analysis that supports informed decision-making across a very wide range of communications technologies. That in and of itself is also challenging. It includes evaluating new wireless technologies, studying spectrum sharing techniques, supporting equipment authorization, managing the experimental licensing system, which I'll talk a little bit more in the future too, conducting actual lab testing and analyzing, interference and propagation issues that come up. One day we might be looking at, the technical characteristics of a new satellite system. Another day we might be evaluating some innovative spectrum sharing approaches or ideas, supporting, public safety and communications, or even reviewing emergent technologies like AI-enabled radio networks. The specific technologies, that they change, but the underlying mission always remains the same, right? Applying sound engineering to help ensure efficient, reliable, and innovative use of spectrum. So I think this is very exciting. And what makes this especially exciting is that communication technologies continue to evolve rapidly. Whether it's next-gen wireless networks, non-terrestrial communications, or new approaches to dynamic spectrum access, OET has the opportunity to study these technologies right early and to help establish a technical foundation to support future innovation. For consumers, much of this work is invisible, and that's probably a good thing. That is the case. When a wireless device works reliably, when services coexist without harmful interference, and when innovators can bring new things to market, it's often because a great deal of engineering work has already been done behind the scenes. So I'd like to say that maybe it's good if folks don't know exactly what we're doing every day.
So you're sort of the technical backbone of the commission. So how exactly do you work with the other bureaus and offices? So we have like the Wireless Telecommunications Bureau, obviously very spectrum focused, the Enforcement Bureau, the relatively new Space Bureau, which is becoming increasingly important. How do you work with them to ensure that the decisions that the commission makes are grounded in consistent engineering analysis? What's the working relationship look like with those other bureaus and offices?
Also a good question. So one of the things that I've learned about coming into the FCC recently, one of the strengths of the FCC is that it brings together experts from many, many different disciplines. Never did I think at a point in my career I would work hand in hand with attorneys every day, and economists and engineers, and geographic information systems specialists, policy specialists, technologists. They're all contributing, different perspectives to the commission's work. Our role, providing a technical foundation allows us to actually support a lot of those different bureaus and offices that you described. So, we work very closely with virtually every bureau and office. Chairman Carr is very supportive of sort of matrixing the work that we need to get done, right? So whether the topic is terrestrial, wireless, satellite systems, broadcasting, public safety, communications, or equipment authorization, they're very important technical questions that we need to evaluate, objectively. So one of the things I appreciate most is the collaborative nature of that work. Engineering isn't something that happens in isolation. We engage with colleagues across the commission, as well as with industry, academia, standards organizations, and also other government agencies as well. That exchange of technical expertise helps us much better understand these emerging technologies and develop engineering analysis that are both practical and forward-thinking as well. So our goal is to be consistent, provide consistency, to provide technically sound analyses that help the commission make informed decisions. So while different bureaus naturally have different responsibilities, everyone benefits from having a common engineering foundation rooted in, essentially in objective analysis and sound science. So we spend a good portion of our time essentially in collaborative meetings and participating in the work that each other need to provide.
So engineering evolves pretty rapidly these days, especially when you fold in AI and all sorts of other things. The regulatory processes we all know too well can often move much more slowly and deliberately. So how do you help ensure the FCC decisions remain technically sound, but not get ahead of either the science or get ahead of the commission's legal responsibilities, move the engineering too fast that the legal responsibilities haven't quite caught up yet? How do you avoid doing that?
Yeah. Well, I think one of the great strengths of engineering is that the underlying principles themselves, the science, essentially are objective. So technologies change, business models evolve, but the law of physics remains constant. So OET's role is to provide the commission with technical analyses that is grounded in measurement, technical analyses that are repeatable, experimentation, and and engineering rigor, regardless of where a particular technology may be in its development. So I benefit from that. It's important, also to recognize that good regulation doesn't try to predict every innovation. Instead, it sort of establishes frameworks that are flexible enough to accommodate advances that maybe we can't fully anticipate today. That's one, reason why technology neutral rules are so valuable, right? They allow innovators to compete based on better engineering rather than prescribing a specific technical solution itself, as I did in some of my previous portions of my career. At OET, we spend a great deal of time evaluating coexistence, propagation characteristics, interference mechanisms, and basic overall system performance. So those engineering fundamentals, help ensure that the commission decisions are based on evidence rather than assumptions. So ultimately, I would say, our goal is to provide technically sound analyses that enable this innovation while protecting existing spectrum users. When engineering is done well, again, it creates confidence for regulators, industry, and consumers alike. Repeatable analyses. So we will be working more with some providers to actually provide good data models and good propagation models and things like that for being able to be more predictive.
So some of these emerging technologies we were talking about earlier, like AI, satellite systems, quantum sensing, which is actually something we've done a webinar about in the past. Some of those things develop considerably faster than traditional standards, particularly AI. I mean, it's moving, it changes every week. How does OET decide when to begin studying a new technology, even before there's an established clear regulatory need? How do you decide what technologies to go off and start studying in more detail?
Iteration, certainly iteration. We have a group of fantastic engineers in OET that are, that understand that one of our primary responsibilities is to look over the horizon, right? By the time technology reaches the point where regulatory decisions are needed, much of the underlying engineering has already been developing for years, right? So our goal is to understand those technologies early enough that the commission is prepared when important questions arise. We pay close attention to advances coming from industry, signals from academia, standards organizations, startups in the space economy, in the space 2.0 economy. Listening to some of those startups has been very important, especially from an experimental licensing perspective. We also look toward analyses and studies that are done by government research laboratories. We maintain an active dialogue with engineers across the communications ecosystem. It's often where we first see new ideas sort of beginning to mature. The scope and span of the systems that our team are tied into is impressive. So not every emerging technology ultimately requires regulatory action, but certainly understanding the engineering early allows us to ask better questions. How does it use spectrum, right? How does it coexist with incumbent services? Does it improve efficiency? Are there any new interference mechanisms that we need to understand? So I think whether we're talking about AI-enabled, wireless systems, integrated, satellite terrestrial networks, dynamic, spectrum access, or even future sensing technologies, our objective is to just build technical understanding before regulation becomes necessary.
Okay.
That preparation, helps ensure that the commission can respond thoughtfully, I should say, rather than, reactively.
So you mentioned the experimental licensing system, which many of us know is very important to early stage research and development for new ideas. It's also important to standards development. We made good use of experimental licenses when doing propagation testing for CBRS in the early days and things like
Sure.
that. So what are OET's current priorities for keeping the experimental licensing system agile and accessible? How can we as industry or academia, because we also have academic members, make the best use of the FCC's experimental licensing tools to expedite the path from research to commercial deployment?
Excellent. Listen, I think, innovation starts with experimentation. Before new wireless, technologies become commercial products, they need opportunities to be tested under real world conditions. And that's exactly what the experimental licensing system is intended to do. I can give you a real world example that early in my time with OET was, during the last government shutdown. And one of the first systems, that I realized was inoperable was the experimental licensing system, because I received phone calls, right?
Yep.
So you always know how important something is when your customers contact you when it's down. So our goal is to make, the process, as efficient and as accessible as possible, while continuing to, protect existing spectrum users. So those two, objectives go hand in hand. Experimentation, depends upon flexibility, I should say, but also depends upon maintaining an environment where other authorized users can continue to operate reliably. So I encourage, innovators to engage with FCC early in their development process, right? So whether you're a startup, a university, researcher, an established company, I think early conversations often help identify the most effective licensing approach and can help streamline a path towards successful testing. So one of the most exciting things we're seeing today is that experimentation increasingly involves collaboration. Companies, universities, standards organizations, increasingly sophisticated technologies from other AI-enabled networks, and to advanced spectrum sharing and non-terrestrial communications. The gamut is covered here with the experimental licensing system. It helps provide the environment where those ideas can be explored safely and responsibly, and folks can experiment and coexist together. Ultimately, today's experiments often become tomorrow's commercial services. So supporting that information pipeline is paramount. And it's a big part of our mission, especially moving into the next year or so, where we are taking a deep dive into the processes and requirements for obtaining an experimental license.
Interesting. Okay, we will stay tuned for that. So, to that topic, some of the FCC's existing spectrum coordination processes still understandably reflect workflows that were developed a long time ago, decades ago. In fact, there's still, like in Part 101, if you look there's still some talk about faxing coordination parameters back and forth and things like that. But, even when you modernize to where we are today, the workflows are still relatively antiquated compared to the speed at which engineering is developing. So as we move to an era of AI-assisted engineering and trying to move towards increasingly dynamic spectrum access, how do you think the Commission could modernize those technical coordination processes while maintaining confidence and transparency in spectrum use? And where, kind of a broader question, a good question for you, given your background, where do you see AI having the greatest impact on wireless engineering over the next 5 years?
First, can I address the fax question?
Yes, excellent.
Going back to our previous question, we are seeking out portions of the experimental licensing process where we are asking for information that maybe is not required, in actually obtaining that license. For example, a fax number, or even having a form on the screen that doesn't allow you to continue if you don't actually enter a fax number. So just one more plug on experimental license applicants. We are very open to hearing from you and hearing about your experience using the platform throughout the years and looking towards ways that we might be able to do things better. Right. So let me close off the facts.
Perfect. Yeah, perfect.
And move over into the question around AI, because it really does represent one of the most significant, I'm going to call it, engineering tools that we've seen in many years. Right. There's AI, within an organization for use within. There's AI for use, on top of as well.
Right.
So it's important to sort of view it as an enhancement to engineering expertise. In most cases, rather than a replacement for it. The opportunity is to use AI to help engineers analyze larger data sets, more complex scenarios, and to make better informed decisions more efficiently. I don't see it as replacement technology. Within wireless communications, since you mentioned that as well, I think it's a little bit of a different vantage point, but I think AI also has tremendous potential. It can improve spectrum utilization. It can help optimize network performance, enhancing sort of interference detection, looking or to strengthen cybersecurity by looking for patterns. It can look at things that are not necessarily at human scale, beyond human scale. It can help networks adapt dynamically to changing operating conditions. these capabilities, become increasingly important as wireless environments grow more and more complex. But from a regulatory perspective, I think modernization also means improving tools that we use to evaluate engineering information. Many spectrum coordination processes, were designed for an era when systems were relatively static, to your point.
Yep.
Today's networks are increasingly software defined, cloud native, capable of adapting in real time. Our engineering, tools and analytical methods, should continue to evolve alongside with those technologies and their evolution as well. Right. At the same time, confidence and transparency remain essential. So I think any AI-assisted processes, must produce results that engineers can understand and validate. I think validate is a keyword here as well, and ultimately be able to explain post-validation. So engineering decisions still require, human judgment at some point in the chain, accountability, and some technical oversight. In the past, I've talked about this sort of default to safe mindset, where trust is sort of fundamental, where a default configuration is the safest configuration. So I think AI should help us make better engineering decisions, but those decisions must remain grounded in sound science, right? So again, validated models, and careful testing come into play as well. So this validation layer, I think, is a concept that's very interesting, especially when it comes to things like AI RAN and other operational tools where AI is making its way into operations. So I think that's how we can responsibly realize AI's tremendous potential, in wireless and in some other areas as well.
So, moving on to one of the most, if not the most significant development in wireless, and that's the integration of satellite networks with terrestrial cellular networks to enable direct-to-device services. Very big topic, very hot topic right now. From the OET perspective, what are the biggest engineering challenges in enabling these systems to coexist successfully? So the satellite networks with terrestrial networks, but also the whole satellite terrestrial supplemental coverage with other networks that happen to be operating in the spectrum at the same time. What are some of the biggest engineering challenges?
Well, D2D, direct-to-device communications, certainly represent, as you said, one of the most exciting developments in wireless, because it's blurring that, what was traditionally seen as a distinct boundary between terrestrial and satellite networks, right? From our users' perspective, the goal is they just want their device to stay connected wherever they are. So I think achieving that vision, requires some solving very sophisticated challenges. You used a word that I've used multiple times, in the question during this talk today. The word is coexistence.
Yep.
Right. So I think that's the first challenge. We're bringing together systems that were originally designed with a very different operating environments, very different sort of coverage patterns, different power level requirements, and propagation characteristics. I think making sure those systems can operate together without causing harmful interference, requires very careful engineering, extensive modeling, and real world testing. So, timing and synchronization also kind of become an increasingly important, characteristic to consider, where satellites are moving, relative to the users on the ground, while terrestrial networks are highly optimized around a more fixed infrastructure. So integrating those two architectures in a seamless way requires, advances in radio technology, network coordination, device capabilities, these sort of things that I've been talking about, innovation. And OET's role there should be to enable that type of innovation. So it's encouraging where we see such tremendous innovation across the industry. So improvements in signal processing, antenna technology, software-defined networking, and increasingly intelligent radio systems are making these capabilities possible today that would have seemed impractical just a few years ago. So from OET's perspective, I think our responsibility, is the same. It's to understand the engineering, it's to evaluate coexistence, to provide the technical analysis that helps enable innovation, while ensuring that existing spectrum users can continue to operate successfully. When we get that, engineering right, consumers will experience something very simple, a device that just always stays connected.
Yeah, yeah, good point. So let me pivot to sort of an age-old question. So spectrum is always becoming increasingly utilized. We're getting to the point where, spectrum sharing is sometimes necessary. How does OET determine whether exclusive licensing, unlicensed access, or some type of dynamic spectrum sharing is the best technical approach for a particular band or set of services? And kind of related, how do the innovations like cloud native radio network and advanced coexistence technologies influence your thinking about sharing versus exclusive versus unlicensed?
Thanks. It's a great question. When I was previously working domestic wireless carrier, I was very singularly focused. In this role, one of the most important things to recognize is that there really isn't necessarily a single spectrum management model that's appropriate for every band, I think, or every application. Different portions of the spectrum have different propagation characteristics. There's different incumbents there, different technical requirements. So the engineering, should help determine which framework is best suited for a particular situation. So whether licensed, unlicensed, shared access, they each have important roles to play. Licensed spectrum provides certainty, for large scale, infrastructure investments, whereas, unlicensed spectrum has been an extraordinary platform for innovation, enabling technologies that now, at least certainly in the United States, have become part of everyday life. Dynamic sharing, also continues to evolve as advances in sensing, automation, and call it coordination, make increasingly efficient use of spectrum that possible. So, with all that said, what's particularly exciting today, is that modern wireless systems are becoming far more intelligent, like we talked about with the AI overlays, not just in operations. Cloud native architectures, software-defined radios, AI-assisted optimization, and advanced coexistent techniques will allow these sort of networks to adapt in real time. We're seeing it already, right, in ways that simply weren't possible as short as a decade ago. So this creates opportunities to improve spectrum efficiency while continuing to protect incumbent operations. At OET, circling it back to us, we don't begin with a preferred licensing model. We begin with the science, we begin with the engineering, we begin with the physics. We ask, what are the propagation characteristics? What level of reliability is required? What are the coexistence mechanisms that are available? How mature is a particular technology? Those types of considerations help inform a broader, policy discussion, quite honestly. So ultimately, I think as we move forward and as we've been, good spectrum management is about maximizing the value of a very finite national resource, and better engineering allows us to, to use that resource more efficiently than ever before, actually.
Okay, good. We have one bonus question to ask you before you leave. No, it's not hard, but so you've spoken about AI RAN. RAN means radio access network, and the concept of default to safe with AI. To the extent that anybody can predict where AI is heading, where do you see AI having the greatest impact on wireless networks? Is it a spectrum efficiency? Is it a network resilience? Is it some combination of both and other things? But also, what engineering questions with regard to AI and its application to wireless networks, what engineering questions remain unanswered?
I think the answer is yes. I think that AI has the potential to sort of fundamentally change how wireless networks are designed, operated, and optimized, which may be one of the more important parts of how it's going to be leveraged or is being leveraged. I mean, historically, we've relied on engineers to configure networks based on, expected operating conditions or maybe patterns that have existed throughout the course of a day, a month, or a year. But I mean, increasingly, AI kind of gives the ability to build networks that continuously observe and learn and adapt to changing environments. So in ways that improve efficiency, resilience, and performance. So we're already seeing opportunities in areas like dynamic spectrum optimization, lots of creativity out there around that now. Also with interference detection, predictive maintenance for different portions of the core networks or even the edge networks, gaining energy efficiencies and looking at network automation as well. So I think as wireless systems become more software defined and increasingly cloud native, AI will just become it'll be a new AI stack that exists on top or sort of orthogonal to that cloud native stack, right? It can help manage levels of complexity that would be difficult at human scale to address in real time. Right? So at the same time, we need to approach these capabilities responsibly, right? So that's where the concept of default to safe becomes important. I think AI should enhance engineering judgments, not replace it. AI assisted systems need to be transparent, trustable, verifiable, should be able to coexist with other systems and capable of producing results that engineers can understand and validate. So trust is earned through that rigorous engineering and careful verification that occurs. Looking ahead, Andy, I think one of the most exciting opportunities is the convergence of, as you mentioned, AI, cloud computing, any advancement, and advanced sort of radio technologies, right? These capabilities together have a tremendous potential to make wireless networks much more adaptive, efficient, and more resilient than ever before. So I'll sort of close it out and say at OET, again, our role is to understand those technologies and evaluate the implications to help ensure that innovation develops, on a foundation of sound science, sound engineering. If we maintain that engineering discipline, I believe that AI will become one of the most powerful tools we've ever had for advancing wireless communications.
Okay, excellent. We'll leave it at that. Andy Hendrickson, the chief of the FCC's Office of Engineering and Technology, on setting the standard. The FCC is sort of the ultimate standard setter for the U.S. spectrum use. So we're really glad to have you on the episode. We really appreciate it, and hopefully we'll be talking to you again soon at a WinForum meeting or some other meeting.
I look forward to it, Andy. Thank you very much for having me.
Thank you very much.